Welcome to Walk About the Galaxy, the naked astronomy podcast, where the science is universal, the opinions are personal, and the introduction is attention-grabbing.
The Naked Now.
We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from beneath the Saharan dust-clouded skies of Central Florida. Stick around at the end of the episode for some epic callbacks to the beginning of the episode.
Really?
Really?
Yeah. Okay.
I'm not lying. Sometimes I lie about why you should stick around to the end of the episode. This time I am not. Our stumpers today are couch potato-y.
Okay.
A lot of us have been, I shouldn't say a lot of us, I have been succumbing to the lure of the couch potato.
Oh, yes.
Or the lure of the couch to be a potato. Maybe more than I ought to or normally would these days. And the oppressive Florida summer heat has been a contributing factor to that. So, Jim, just straight up simple, I don't know if you've been facing this problem or not, but Netflix or Prime?
Well, I do like to chill.
Can you chill with Prime? You can't.
You could.
It's just not how it. That's
Prime
not how
is
they
That's
show
not
say
how the
it.
phrase goes.
That's
Prime
not how the
and
phrase
Prime needs
goes.
its own slogan, like catchphrase like that.
Yeah. In reality, I love them. We have both of them. I like them both. I would pick Prime if I had to only pick one, because if there's a movie that you want to watch and it's not on those things,
You
on
can buy
Prime
it
you can
through-
buy it on,
right.
and Netflix you're just screwed. So
Right.
It's true.
Prime. I'm gonna Prime and chill.
I feel like I've been watching a lot more Prime lately.
Yeah.
Some of
Yeah,
the series
it had
on there.
The Expanse.
The Expanse, which
And,
you
I
both
mean,
have concluded.
Alias.
There are a lot
is-
of great things on Netflix too, don't get me wrong.
Yeah.
But we've been watching. I don't know what we've been watching.
Shows.
Shows,
Okay.
things.
Maddie, yours is a little bit more out there in left
Yeah.
field. Oh, gosh.
Oh my gosh.
Quibi or
I
TikTok?
think it's Quibi.
Quibi?
Yeah.
I almost made a very inappropriate joke.
Oh my. So
I was
This-
gonna.
we were. You
I
didn't
think
though.
I think it's
And
good you
then-
didn't.
I
I see where you're going.
It's
It's
because
good you
Finn
didn't.
is looking at me. My little poodle is looking at me. I felt embarrassed.
Oh, we need you all the time, Finn. So I actually have no experience with either of them.
I've never even heard
What
of
are those
Quibi.
things?
I have seen people doing the TikTok.
TikTok started to like, here's a dance move kind of thing or something?
It's like it's sort of like a more interactive version of, this is going to be old person speaking right now, because it's like the kids these days are doing it.
Right.
But it's basically, little short videos that then people like basically try to reproduce them and then post their own versions of them. And so they're little short videos. And then this Quibi platform is supposed to be this new, like, very short, like 7-ish minute movies and videos and little shorts that people are putting out.
Oh.
But it's more like a little bit more professional. And then TikTok is like you and your friends make little videos.
Okay. So Vine was like 7 seconds, but
Yes.
neither of these has that sort of ridiculously short limitation.
No.
Okay. Maybe that's why they're still, or they exist.
Quibi is it's some name that comes from 2 words.
So
Quick
which one are you-
bites or
which one are you
something
picking?
like that. It's like quick bites or something like that. I'm gonna pick TikTok
Okay, because of Sarah Cooper.
because of Sarah Cooper and the kids like it.
Okay.
I'm pretty sure nobody's ever gonna like Quibi.
Well, believe it or not, today we will be talking about some astronomy type
Yay!
stuff. Well, we've got big, massive things running into each other,
It's
and
not just us.
slightly
We're staying physically distanced.
We are staying physically separated, physically distant, and slightly less massive things orbiting each other.
Cool.
In our science. So black holes, neutron stars, exoplanets,
The huge.
exomoons. Yeah. Right. But first, this episode of Walk About the Galaxy is brought to you by Zodiacal Light. For the explorers of the Antarctic Sea, there's the Zodiac. But if you're an explorer of even more distant realms, align your telescope to the stars and pop open a can of Zodiacal Light. With an effervescence that will have you feeling the glow of interplanetary dust warmed to a balmy and isothermal 300 Kelvin, give or take, Zodiacal Light is the perfect accompaniment to an evening of stargazing, comet hunting, planet watching, or astrophotography. Without all the calories of other late-night libations, let Zodiacal Light be your refreshment on your walk about the galaxy. Zodiacal Light tastes great, less filling.
Bud
I
Light.
didn't realize Zodiacal Light was 300K.
Michelob.
The dust was 300K.
I said give or take.
Okay.
It's at about 1 AU. Most of that dust is sort of 1 AU-ish.
Okay.
And it's
about right.
small enough so that
Yeah.
the sunlight heats it up through and through.
Yeah.
So you don't have day side, night side
Yeah, yeah.
asymmetries. It could even get warmer if it's so small that it has trouble radiating in the
It's true.
infrared.
It's true.
If its emissivity is less than 1.
Anyway, thanks,
I
sponsor.
didn't. I originally Zodiacal Light had all of those details in their sponsor
Yeah,
message,
but you
and I
trimmed
suggested that they maybe cut those out.
it down. That's reasonable. Jim called the slogan.
It was a beer, a light beer.
Which one?
Michelob Light.
I thought you said Bud Light first.
I did.
You changed it.
Yeah.
They're
Okay.
both wrong.
Damn it.
It's more Miller Light.
It is Miller Light,
Yeah.
and now Zodiacal Light.
And now Zodiacal Light.
Fair enough.
Maybe if I make a beer again soon, I'll call it, and I make it a light beer. I'll call it Zodiacal,
Zodiacal Light.
Yeah.
All
How do you
right.
spell it? Lite?
Yes.
Okay.
Because it won't actually be a light beer, because gross.
Oh, okay.
And I don't know how to make this.
Well, you could call it Zodiacal Light Lig, because Miller Light is Lite.
Yeah.
And you could make yours Zodiacal Light Light.
That's
and
too
just
that's
have
too
a
literal.
nice picture of the Zodiacal Light on
I could.
the bottle.
On
I
the
was going to
can.
say on the can, but I guess you probably won't be in a can.
I usually bottle.
Space news. Usually, I'm fond of saying another episode of Walkabout, another Starlink launch, but
But it got postponed.
it's been postponed. The launch that we were advertising on our last episode has now been postponed to sometime, perhaps even after the next launch,
Yeah.
because SpaceX has a GPS satellite they're supposed to launch for Uncle Sam next week, and my guess is they'll probably push the Starlink launch to after that.
That's what they've been talking about. Yeah.
Both of their ships that these rockets land on are out to sea,
Yeah. Of course, I Still Love You.
and
And the other one.
Mr. Tree's Amazing Adventure.
No, Miss Tree and Miss Chief are the catchers, the
Yeah,
fairing
I don't-
catchers.
I don't know what they are.
It's Of Course I Still Love You and the other one.
That's the name of a boat?
Of Course I Still Love You is the boat, yeah.
Yeah,
And then it's the barge.
yeah. They have station keeping engines so they can lock
Yeah.
themselves in a particular set of latitude and longitude and just hang out there.
Usually one of them stays here in Florida and one of them's out in California.
They're both in the Atlantic at this moment.
Yeah.
So that's one thing of space news. So
There was a
in
spacewalk today.
There was a space. Yeah, you were just talking about that on the TV.
I was on the TV box
on the TV box
and the internet, I guess.
What's going on in space?
They replaced some batteries on the space station. Ooh.
What?
I know.
Why do they have to go
crazy.
outside to replace batteries on the space station?
Because that's where they keep
Seems
them.
like a crappy design, right? Shouldn't they be able to change it from inside?
No, I mean they didn't plan on it, right? Like these batteries they've been over the course of like the last few years replacing the old batteries with chemistry I can't remember with the new nickel hydride batteries with new lithium ion batteries. And so they had like 48, now there's going to be 36, but they're like higher energy density or whatever and they're better batteries.
Yeah, I mean, you can't have everything serviceable from the inside. And on the
Yeah.
inside, there's the astronauts have to live, and there's experiments you have to do.
Yeah.
Yay.
Where you need to be interacting with those every day,
Right.
and so
But you'd think, yeah.
Well,
You'd
I mean, I don't think they planned on
behind
replacing the
panels
batteries,
and things
right?
like that, you'd be able to, what?
But I don't think they like planned on replacing
You don't
the
plan to
batteries.
replace, but batteries run down.
But I mean, they've been up there for 20 years or something
Yeah.
before they started replacing them.
Really?
And like we didn't
So these
know
are
how
the
long
original batteries
Yeah,
that
yeah,
are-
yeah.
Okay.
So like we didn't know how long the
wish
ISS
my
would
car
last.
battery lasted that long.
Yeah,
Right?
seriously.
Yeah.
My car batteries are boat batteries. I mean, you got a couple years, 3, 4,
I
5,
guess
6
that's
years,
the
and
difference
that's it.
between $20,000 and some number of billions of dollars for your vehicle.
Yeah.
In addition to the SpaceX Starlink launch delay, the launch of
Percy.
Perseverance, the next Mars rover, has been delayed a couple days.
Yeah, they can't delay it very much.
The launch window is how long? Do you know?
A weekish.
Something
I
on
would
that
assume.
order. Yeah. This is to launch the next Mars rover, and sometime, like, launches to the space station, the launch window is instantaneous. You go or you don't go at that time each day. For planetary stuff, there's always a little bit of a margin. The launch window for the Mars rover Perseverance is based on the relative positions of Earth and Mars in their orbits around the sun. And they've got a little bit of margin in fuel so that the optimal time is usually in the middle of the launch window. So frequently a slight delay, while they don't do it on purpose for that reason, actually gives the rocket a little bit more margin. I know for Cassini, when it launched back in 1997, it was delayed some into its launch window, which was several weeks long, maybe 3 weeks. But each day of delay meant that it would have a little bit more fuel in the tank after it arrived at Saturn. I think for the Mars rover, it doesn't really matter because you just like land the rover on Mars, and for the rover, it doesn't matter at all. So it doesn't really matter.
I will correct myself. They have replaced the batteries before, but they've been replaced since 2017. They've been replacing them with the lithium ion, but they had replaced parts of them before.
Yeah, I mean, I guess it depends on the chemistry. I mean, there's all kind of different batteries, right? Our batteries for your car are lead batteries, and those things probably do run down a lot quicker than other kinds. I imagine these new kinds will last a very long time.
Yeah. 10 years.
10 years, and that's probably about the remaining lifetime of the space station.
Hopefully.
Other things have limited lifetimes as well. And those are the parts that the people rely on to live.
Yeah.
So
There's been some announcements this week about NASA flying astronauts in suborbital vehicles. So they made an agreement with Virgin Galactic and to fly their astronauts on suborbital vehicles. And then also some announcement that was sort of like glossed over about flying astronauts to the station. Private astronauts, I think.
Also, is that maybe that's the same thing that I was going to mention, is that Russia is now back in the selling tickets to the space station business because NASA had been buying all the available tickets to the space station from them. Now NASA won't be doing that anymore. And so Russia's got, all right, let's get back in the tickets to ISS business.
It'll be interesting to see if people buy their tickets or like SpaceX tickets.
Yeah. I guess we don't really know exactly what the costs are for each. Yeah. I don't know if you got 20 million, 30 million lying around.
I'm going to go check my piggy bank.
Okay.
Yeah. So you're, I'm sure, madly scheming for great science projects that will require your physical presence on the Spaceship Two or New Shepard rocket.
I mean, I'm doing accurate scientific hypotheses about what might need to be done.
I'm sorry. Did I say madly scheming? I meant
me involved in the loop in my experiment because it's very unreliable when it's done without a human in the loop.
Right. And that's because it's intrinsically impossible to do it any other way. It's not because you didn't design a good experiment that could run on its own.
It's just that there are natural challenges when you have to automate things and rely on sensors. That's much easier when humans are doing it. Yeah. And actually, some of that's very, very true. So
it is.
Not just making up a trip for myself. We've had lots of problems with having to automate things.
We're on the airplane with an experiment and then flying a similar sort of experiment on rockets. And the experiments generally go better when we're with them on the airplane. Yeah. Although the environment is better usually on the rocket.
Yes. Anyway.
So let's talk black holes.
All right.
Sweet. That's a pretty common...
Everybody's favorite astrophysical topic.
That's right. Well, and we're getting to talk a lot more about them recently for good reasons. One of them, of course, is the LIGO and LIGO Virgo thing where we're measuring gravitational waves. So obviously that was a huge thing, and we've seen many, many of them since then. And so I think we have two cool gravitational wave detections to talk about today.
Okay. Are they both from LIGO?
Are they
both of them involve LIGO but aren't only LIGO?
Are they too cool or is there two of them?
No. Two separate things.
Oh, okay.
The first one is a cool three black hole thing, kind of. So that is one place where you can find a lot of black holes if you really want to is
I do want to.
You do want to?
Is this
I want to.
Well, where would you go check it out if you want to go find a whole bunch of them?
I would go to a globular cluster,
A globule. That's one place you could go.
the center of the galaxy.
Ooh, that's even a better place, right? Because the center of the galaxy
Are these bars?
has a pretty dense population of stuff, right? And some of that stuff are black holes. And so recently
Do they,
there was a
sink to the center
gravitational
of the
wave
galaxy?
detected from a region, near a supermassive black hole. And the cool part about this is almost none of the gravitational waves we've detected so far have optical or electromagnetic light counterparts, right? Only one of them. That was when the neutron stars collided.
Right.
Because black holes colliding don't produce any light. They just produce gravitational waves. But they do produce light if those two colliding black holes are in the environment around a supermassive black hole.
Oh.
Such that there's a lot of other junk around, right? There's all this big accretion disk around the supermassive black hole. Then the two regular size-ish black holes, right, 10-ish solar mass black holes, collide into each other, cause this big disturbance in the accretion disk.
The force.
What's that?
Do they cause a disturbance in
They
the
cause
force?
a significant disturbance in the force. And we see that disturbance both in gravitational waves and in light.
Whoa.
So that's kind of awesome.
Wait a minute. I missed something because I was thinking about Star Wars.
Sure.
As one does.
What's
So these are. This is
What's
a
the
distant
light-
galaxy.
what's
This is not our galaxy. This is a distant galaxy.
well, whatever.
Phew,
Let's
we're
put it in
safe.
whatever galaxy we want.
Right. So there's a supermassive black hole. Around that supermassive black hole is an accretion disk.
Yes.
Of stuff.
A bunch of stuff that's gradually it's hot.
It's very hot.
It's compressed.
Yeah, it's-
and some of it, because of friction, loses energy and spirals into the black hole.
Right. So this event is not something spiraling into the black hole. This is two black holes in or near that accretion disk colliding with each other,
Okay.
causing a disturbance in the accretion disk, which causes electromagnetic radiation.
Okay.
And so we can
what
sense,
kind of-
we can see both the gravitational waves from the collision of the black holes and the electromagnetic radiation
what
from.
what kind of disturbance is it causing in the
Well, it causes
in the
a.
light from that disk? The light from that disk, it's like glowing
Sure.
at all sorts of wavelengths because it's super hot.
Sure.
So we're seeing.
But the big gravitational disturbance of that thing causes it to be significantly hotter, right, for a short period of time.
heats it up.
Right. It heats it up. It mixes it up and heats it up for a little while. And then, so we're actually kind of excited about this because it also, that combined black hole that those two things merged into is probably now on a trajectory that's going to head it into the supermassive black hole. And we should see
snap.
yet another big gravitational wave thing in a few years when that
that
falls
soon?
into the.
I
Yeah.
was ready for you to say in 100 million years.
No,
or
I think in a time scale of years. Yeah.
Really?
Yep.
Pretty exciting.
So that's pretty cool. That's a prediction we can make, and we'll see if we actually see gravitational waves coming from there. But that's a now.
So was this light was observed?
Yes. So the light was now. We should be careful.
It was
This, of course,
observed.
this is a hypothesis for why we've seen what we've seen, and it's well matched by models, computer models that we make. So we saw you'll see the light significantly weeks after you see the gravitational wave, because it takes the light longer to propagate out through this thick accretion disk. The gravitational waves just travel at the speed of light.
The gravitational wave travels at the speed of light, and one of our favorite things is that light doesn't always travel at the speed of light if it's going through stuff.
That's right. Light in a medium travels more slowly, and so it gets slowed down, and we see a delay between when we see the gravitational wave and the electromagnetic. And the delay was precisely what we had modeled the delay to be, and that was one of the big clues that this is what was happening. So that's kind of neat.
It's kind of cool.
Okay.
Lots of really interesting dynamics happening there.
Yeah.
Crazy spinning.
What kind of optical detection was seen? I mean, what?
So unfortunately, we didn't get as much information about that as I wanted. So this is picked up on one of these like transient surveys where you're just looking for blinks of light, and it happened fast enough, and it was only seen kind of after the fact. So we didn't get to stare at it with telescopes, significant number of Earth-based telescopes around. So we don't have a spectrum of the signal. We just kind of have a blip of light, and I don't even remember. I don't even know off the top of my head what.
So it's a short blip.
It's a short blip.
Right. Okay. And just as a reminder, when these black holes run into each other, they then all your mass is like inside one black hole.
Right.
After that, and we can't really say what's going on inside the event horizon of that thing.
Right.
But the new mass of the two things that collided is less than this. The whole is less than the sum of the parts.
That's right.
Contrary to all team building lessons that we've heard over the years, because and where that missing mass went, it was converted to the energy of the wave,
That's right.
of the gravitational wave, and that energy is equals mc squared, where m is the missing amount of mass.
Right, right. And this missing amount of mass tends to be on the order of a few times the mass of the sun. So
it's
it's
a
a tremendous
ginormous
amount of energy.
Amount.
And so
Is it tremendous or ginormous? Because I thought it was
both.
okay. And okay, it's just it's interesting. The whole gravitational wave thing just is cool.
Yeah, and the gravitation, like these flares were observed, but they haven't like confidently like linked it to the LIGO event.
Right.
Yet.
So actually,
there's, like a little asterisk in it.
right. There's and in fact, the kind of scientific paper that LIGO will put out about that event has not been put out yet. So they've released preliminary details about it, roughly where in the sky it is, and that business, but they haven't.
LIGO's always been a little bit hesitant to put out. It's been my observation.
Oh my.
But soon, but the authors of this paper talking about this are think that's kind of a cool thing. So when this paper comes out, they'll be able to kind of more closely match what they saw with what LIGO saw and actually confirm whether their reasonable model and hypothesis is right.
Yeah, there's the like public alerts when LIGO and Virgo detect things.
Yeah.
And there was like one that went out about this thing. So there's an indication that it's happened, and I'm sure they've talked with the LIGO folks.
Right. Right.
But when LIGO saw this particular detection, they like put out an alert, I guess, that says we saw this thing,
Right.
but they can't really say where. They can just sort of say like over that away.
Well,
right?
yeah, kind of. So I mean, now that we have LIGO, which is with its two detectors, and Virgo the third, we have better spatial resolution about where it is. Not exactly. I'm not going to say it's in Galaxy NC whatever. But they're going to say it's generally in this broad area of the sky. Then you go check your surveys to see if there was any significant electromagnetic radiation, either at the time or a little bit later from that part of the sky, and so that's what they saw.
Yeah, the telescope that found it is the Zwicky Transient Facility, the ZTF.
He's our favorite astrophysicist.
He's such a great name.
Zwicky.
Yeah,
Zwicky. Yeah,
Fritz or Franz?
Fritz Zwicky. That's also the name of one of the meanest cats in our neighborhood. We named him Fritz Zwicky.
Oh, good for you.
Why?
Fritz Zwicky was a jerk in real life.
He had a reputation anyway.
Yes, he had a
we
reputation
don't know
of being
from personal experience.
Right? No, he died.
And we don't want to.
But he was a phenomenal scientist, and he was the first person to suggest dark matter and various other.
Which he was ridiculed for.
Right. No, he's a phenomenal scientist, but prickly. Yeah, I don't mean he's a jerk necessarily. I didn't know, but he was prickly. He was prickly.
Prickly pear.
He was prickly.
Well, speaking of LIGO, I'll drop my trivia on you today.
Oh.
Having been talking about the Laser Interferometer Gravitational Wave Observatory, or LIGO, our trivia is about Lego.
Yes.
From the Danish leg godt, or play well. Lego sets have evolved over the years to now include a lot of number of what are essentially model kits.
Yeah.
To date myself, when I was a kid, you just got a whole bunch of red, blue, white bricks. They were all pretty much the same dimensions.
They were like four kinds, and you made whatever you could
just
out of
stacked
it.
things up and made a whole bunch of like square rooms or very, very unaerodynamic rockets or airplanes.
I did a lot of that.
And
But I
now
also
that
had like a space shuttle. I remember the pirate ship was big when I was a kid.
okay.
It was pretty awesome. I think it floated.
So they've evolved to a lot of their sets now are like model kits. It's like buying a model kit. And they have various themes. So some are space themes. Some are like Star Wars, Harry Potter. So
Ninjago.
a lot. In which?
Nothing.
I don't even know what that is.
It's like the main line for a lot of their stuff.
Really?
It's like Ninjago.
Oh. Well, there is a strong thread at any rate connecting Lego with space and nerddom.
Yeah.
And there's only one letter difference between Lego and LIGO. So our trivia today is about Lego.
Okay.
So your main question, and after that at the end we'll have a couple of simple follow-ups. Your main question is the largest Lego set measured in the number of pieces
Okay.
marketed, produced, sold by Lego, is of what item and how many pieces does it have? Here, it's multiple choice.
Oh, okay, great.
So here are your choices. And don't blurt out an answer.
Great.
The Millennium Falcon from Star Wars. Hogwarts Castle from Harry Potter. The Death Star from Star Wars. The Taj Mahal. Or the Titanic.
Does that one come with an iceberg?
I'm not going to divulge that.
pre
I'm not going
or
to divulge
post-impact?
that piece of information. And so that
A
is
lot of
your
leftover pieces on that one.
that is your set. One of those is the largest in terms of number of pieces Lego set ever sold. And so we'll come back to that towards the end of the show, and then see if you can take a guess at how many.
We've had another Lego
Pieces.
number of pieces question before.
Not
Another
this
trivia, but it was not quite this one.
one. Nope.
Oh yeah, NASA stole our trivia the other day. They said,
And
how
what was
many
the
space-
answer?
I don't.
First, what was the question?
I think it was today, maybe. Oh, I don't know time. It was how many spacewalks have there been?
to service the space station
Service the space
specifically.
station, yeah.
How many
'Cause
space
this was
stations
spacewalk
servicing?
288 or something today.
Whoa.
Total, but
Total.
not space station servicing.
No, because like the last one they did was to fix some stuff with the AMS, the Spectra.
Oh, that doesn't count?
No, because that's an instrument on the space station, so it doesn't count as servicing the space station.
Oh, really?
Oh, that's weak.
Are you sure that wasn't counted in their list?
I am 90% sure.
Okay.
Plus
But
or
I
minus.
thought that the NASA revealed their lack of chops at coming up with good trivia because
All the numbers
while
were
the
too
question
close
was
together.
fine, all of the answers were between 200 and 230. And at that point, I'm like, whatever you guess is close enough as far as I'm concerned. Right. Astronomical precision. It's like 210 or 218. Well, it's 223. Whatever.
It's close enough.
Close enough. Right. Okay. Well, before we get to our exoplanets thing, there's another sort of LIGO related thing in the news.
Yeah.
So Jim has been like so happy.
I've been-
He's so excited by all this stuff that he stopped looking at his stamps for a
Part
day.
of it, part of it is
my.
just like when that first LIGO thing came out, everybody went bananas, right? It was a huge thing in the news and everything like that. And I'm just super happy that it wasn't like just one and done, right? And we've been seeing, they've been putting out a lot.
Yeah, they have.
Yeah.
Maybe it's a
putting out
lot for
they've
you.
been-
For me, I'm still a little disappointed.
Yeah, yeah. Well, you're not playing it right. So this was this detection that we're going to talk about now was cool because, well, for a couple of reasons. One, it had the biggest mass difference as far as the ratio between the two colliding things. Typically, these are things that are, one is 10 and one is 15 solar masses or something. They're similar
Which is the
sized
same.
things.
It's kind of amazing to me. Sorry to interrupt you.
Yeah.
But since I do it all the time, that they can tell they can know the mass of the two individual things in addition to, like, instead of just knowing the total. Like,
Right.
I would naively think you could just know what the total was.
Right. No, but
What's the difference? What happens differently if a 5 hits a 25 versus a 10 hitting a 15 hitting a 15?
Yeah, obviously the thing you end up with is roughly the same, but the signal, because you're watching the signal as these things spiral in towards one another, and then after they merge and ring down or whatever. So the wave forms are different based on
It's
the
a different sounding chirp,
Right,
in some
exactly.
sense. Okay.
Exactly, because there's all kinds of. It's not just how big, the amplitude of the waves, but then there's also the frequency and all this. Anyway, so there's. I don't know the details of it, but they do a pretty good job. So this was a collision between something around 23 solar masses and something around 2.5 solar masses.
Ooh,
2.5.
that's Order of magnitude difference.
Order of magnitude difference.
We care about that.
And the really cool part of it
That's
is
noticeable.
We haven't seen a thing like that before. This 2.5 solar mass thing or 2.6 solar mass thing
Tiny.
is very tiny if it's a black hole, too big if or almost too big if it's a neutron star. So we're actually not sure what it is. It's either the biggest neutron star we've ever seen or the smallest black hole that
Is
we've
it a
ever seen.
neutron hole?
Is there any hope of figuring out which one it is ever?
Maybe there's hope, but but maybe not. We pretty much, this was not a thing where there was electromagnetic radiation associated with it, so we have nothing else to say except what we've seen from the gravitational waves, and maybe we've mined as much information as we can out of that. the way we might know is by doing a better job theoretically of constraining. So the thing is, neutron stars, we're pretty sure, have a maximum possible mass, and it's around that number, around 2.5 times the mass of the sun. Because if neutron stars get bigger than that, they collapse under their own weight. Right.
So for white dwarfs or dwarves, which is it?
Dwarfs.
For white dwarfs, we know pretty precisely
Right.
how massive they can get, which is like 1.4 times the mass of the sun.
Right.
Why don't we know the number for the maximum mass of a neutron star as precisely as
we
that?
know it reasonably precisely, but not too precisely for a couple of reasons. One is we don't understand the state of matter of a neutron star very well. And I mean, this is a big giant ball of neutrons at ludicrous pressures and ludicrous temperatures, and we just cannot reproduce anything like that in our laboratories. So all of our understanding of how these things operate internally is based on theory.
But that's true for like supernovae and
Sure.
and-
Absolutely. It's true for a lot of these things, right? This is one of the hard parts about astronomy in general and
can't just go
and
there.
astrophysics. Yeah, you can't put a neutron star in a laboratory and do experiments on it and stuff like that.
That
That would be
one.
interesting.
It would be freaking
I will
amazing.
not propose to do that on a suborbital flight.
But because we don't understand that very well, we can't put a really hard limit. It also
could be a
depends a
baby
lot
black-
on like the spin of the thing. It can be a little bit more massive if it's spinning, so that it's less dense because it's being thrown apart.
Oh,
and,
wow. Okay.
So there's a little bit of a anyway.
But it could be a little baby black hole.
It could be a
too.
baby black hole. But the interesting thing about that is, even though our ideas lead us to believe there should be plenty of black holes that are around 3 times the mass of the sun, between 3, 4, 5, we've never seen one.
Is that just because they're
Well, how
hard to
would we see one, though?
Yeah.
Well, most of the black holes we've seen before LIGO were seen as part of X-ray binary systems. That is, you see a black hole in a binary star system with some other kind of regular-ish star. The black hole is stealing material from the regular star. That stuff is swirling around and producing X-ray light as it falls into the black hole. And so we've, in our galaxy, seen a fair number of black holes, found them this way. This is the first black hole ever found, Cygnus X1,
X1.
right? X1 stood for X-ray source 1. It's the brightest X-ray source in the constellation Cygnus. And anyway, there are a number of things like this. When we measure the masses of those black holes, they tend to cluster very close to around 7 times the mass of the sun or something like that. And we have seen none less than about 5 times the mass of the sun.
And we're pretty confident you can't make a neutron star more massive than, say, 3.
Right. Right.
So there definitely should be black
So,
holes
yeah, I mean, there
in
should be
there,
black holes.
unless it happens for whatever reason that when the stars that make these things blow up, they just can't blow up and leave intact something as small
Right.
as like
Right.
4 or 5 times the
That's
mass
right.
of the
There
sun.
could be something like that. It could be that when you have a black hole or a star that would make a black hole of that size, that something weird goes on with the supernova that blows
Right.
more of the material off or brings it back in or something like that. So that's what we're guessing must happen, because at first we thought there must be all these.
So how precisely is the mass of this guy known?
It's pretty precise. I mean, it's like somewhere between 2.5 and 2.67 with about
Oh, wow.
95% confidence. So
That's for LIGO type stuff. That strikes me as really
yeah, it's,
really
it's,
good
it's
precision.
pretty precise. And
Yeah.
so, so yeah, it is. I mean, we don't know. Like I said, we're not sure if it's one or the other, but it's either the biggest neutron star or the smallest black hole, and either one
It's a
is
thing.
interesting. Either
It's
one is
a thing
interesting.
that exists at that mass.
Either one is
Not
cool, because if
anymore.
it's a
It's
neutron
right.
star, it's pushing the limits of what neutron stars can be, and that's telling us something. If it's a black hole, that's telling us there are black holes that are that small, and maybe they're not as common as we thought because they're hard to make or are made in weird circumstances. But anyway, it's kind of awesome.
Okay.
Yeah, that's the hard thing though too. Now is we can't like study it again
Right.
because it collided.
Right.
Right.
And now-
We'll
But
have
we,
to see more of
we
these
just have to
things.
sit there and watch LIGO and Virgo and see what other things we see, right? So if we see more of this kind of event, that tells us something.
And you know what you can do while you're sitting
stay
there
home and watch LIGO.
and with a can of zodiacal light.
Can of
Can is zodiacal light.
Yeah. LIGO and chill.
Right.
Yeah, there you go.
Speaking of things orbiting each other, there was a paper that's just been submitted for publication, hasn't been reviewed or published yet, but it's talking about the topic of exoplanets.
Mm-hmm.
So we've seen thousands now of planets orbiting other stars,
Yeah.
and in our own solar system, of course, however you want to count what's a planet or isn't a planet, a lot of them have moons.
Yes.
And so it would be unusual if of the thousands of exoplanets that we've seen, that none of them has a moon or more orbiting them.
Yeah. But pretty hard to tell,
Yeah.
right? We're like sort of like, hey, there's probably a planet there. Maybe
We have to
there's
squint
two.
really hard just to see the planet. Right?
Yeah, right. So like detecting a little thing orbiting a big planet is hard anyway,
Right.
right? There's like we just found a bunch of new moons of Saturn or Jupiter. Which one
Jupiter, I
was it?
think, was the most recent batch.
Yeah. So moons are hard to find sometimes. If it's a more massive moon, so if it was a moon like the Earth moon system or maybe like the Pluto-Charon system, there you have a different mass ratio and it might be easier to find. But it's
Right.
still like
But around another star.
but around
oh
another
my!
star, yeah.
Right. So
So have we done
what
it?
these people did was they
Maybe.
took a look at Kepler data, and Kepler, of course, looked to see if really tiny dimming periodically in a star's light, presumably due to a planet orbiting that star and happening across in between the Kepler Space Telescope and the star. And they would see it, if it dimmed periodically, you could say, okay, that's things orbiting the star. And what they looked at was 8, where it was periodic, but sometimes it would arrive a little bit early and sometimes a little bit late. In other words, the dip would seem to not be perfectly periodic. So there's a lot of reasons why that can happen, of course, right? The most obvious one is not a moon, but it's some other planet in the system that you haven't seen because it doesn't happen to be passing in between you and the star. And that planet's tugging as it goes around the star. It's also tugging on the star and the planet and messing up the timing.
Right.
But another possibility is that a moon orbiting the planet, and as with the Earth-Moon system, the Earth and the Moon have a center of mass. There's some point in between the Earth and the Moon. And I don't know where exactly. Do you guys know where the center of mass for the Earth-Moon system is? It's probably inside
Like
the
a great
Earth, but
trivia
close to the.
I think
it
it's
is a great
inside the
trivia.
Earth.
It is, but it's maybe closer to the surface of the Earth than the center of the Earth. If you were going to balance
Yeah.
I would
them,
bet.
that's where you'd stick
Yeah.
your finger. And so it's
little
that
bubble
point
bubble.
that's actually orbiting the star
Right.
exactly every year. But the Earth and the Moon are spinning around that like a dumbbell. And so depending on where you are in the phase of things and what the orbit period of the Moon is, sometimes the Earth will be on the right side of the dumbbell and get there early, and sometimes it'll be on the left side and get there late. So they were just looked at this and said, okay, could these handful of weird Kepler things be explained by moons? And for 6 of them, they said, sure.
Sure. Sure, they could. No, but they did some analysis and showed that it made sense, right? And like it could be other things. So it could be that there's another planet that that's in a little slightly different orbit that you're not detecting. And so they do models, right, of what these different signals would look like and see if statistically it matches what you would see with this moon. And for 6 of them,
Yeah, it
So
fits.
sure.
It's consistent. What they say is it fits. It's not the only thing that fits, but it's one thing that fits.
Are they making predictions that might be able to differentiate between those two hypotheses?
Well, so Kepler is no longer operational, so we're not.
Yeah.
Right.
And obviously, with further data, you would be able to get a better handle on. And the problem is you only get a data point once every year of the planet.
Right.
yeah.
The Earth-Moon system, they said, would result in like a 2.5 minute variation in when you saw the dip. If you were some alien looking at the sun and you were looking for the dip caused by the Earth, it'd be about up to 2.5 minutes. Kepler only observed each of these things. It recorded the measurements every 1 minute. So it's really not super high resolution for that. And the signals are really, really weak. But it's as with some of the things that we were just talking about in the black hole realm, more observations
Yeah.
Right.
will eventually conclusively identify exomoons, as they are called, moons orbiting other planets.
I mean, it seems like if you really wanted to. So, I mean, the whole Kepler's awesomeness was that it was watching hundreds of thousands of stars all at once. So you could look at just a couple, right? And since you know approximately when these things are going to happen, you could point Earth-based telescopes or whatever at those things at those times. And
I mean,
get
a lot of
better data.
a lot of the planet candidates get follow-up surveys and stuff like that with
Yeah.
sometimes with different techniques, sometimes with the same techniques. And so I don't know, but I don't think the paper really necessarily said like, here's what observation you would want to make. But yeah, definitely like follow-up observations to fit the parameter space would be cool. I also just want to say like, I really like the plots they have in the paper. They're a very nice color scheme, like sort of retro yellows and greens and pinks and blues, and it was just very appealing.
Yeah, kind of had a little bit of a 60s, 70s vibe going to it.
Yeah.
Cool.
Maybe early 90s too in some way.
Well, one of the reasons people are excited about exomoons is that a lot of the planets that we've
they
seen
might have Ewoks.
are right. Exactly. That was a much better explanation of it than I was going to give.
Yeah, because they might be habitable.
Right.
Yeah.
Yeah.
But why would the moons be habitable over the planets?
Because a lot of times the planets are super close in, and so they'd be very warm.
Well, the moon is going to be as close in as the planet.
Yes, that's true.
Part of it is that a lot of those planets are ginormous.
Yes, they're giant gas balls. But if they have
the
moons around them,
the moons can be nice.
They can be nice and sort of the right temperature or warm or have atmosphere.
Might have the right kind of atmosphere
Yeah. So like we study like Titan and Europa and stuff like that. But if you can imagine like moving Europa in a little bit closer,
Yes.
Jupiter gets warm.
Let's do that.
But Europa's
Yeah,
in
then Europa's
closer.
a big giant
Then you have a
ocean
giant
planet.
ocean world. Yeah.
Yeah.
Water world.
We do call them ocean
Water
worlds.
World. I love that movie.
NASA calls
them
ocean worlds, and they with a little asterisk that says ocean may be buried beneath 100 kilometers of solid ice.
We love our asterisks. Ocean world / solid water.
Yeah. Come to the beach. You just need to drill down 60 miles to get there.
I think that's on their exploration poster. Yeah. Should be.
In 2010, the sequel to 2001, the novel by Arthur C. Clarke, Europa was like off limits. Can't go there because aliens.
Makes
also,
sense.
the Europa Report.
Yeah.
So totally,
That's a great
we should bring Europa in closer to the sun. Okay, Legos.
Legos.
Which of the following sets is the largest Lego set ever produced? The Millennium Falcon, Hogwarts Castle, the Death Star, the Taj Mahal, or the Titanic?
This is a little tricky because there have been multiple versions of the Millennium Falcon and the Death Star. My initial thought before you said any options was the Millennium Falcon.
Oh, that was what I was going to guess before you gave the options.
But then I remembered
also.
the Taj Mahal does have a lot of pieces.
All right, I'm still going with my original one.
Millennium
Falcon. Even though you never guess the one that's first.
I'm gonna. It's true. Josh
most
isn't an
of
A
answering
answer
of
very
trivia is
often.
trying to figure out Josh's psychology.
Yeah, that's reasonable.
I'm going with the Falcon.
Students should do that on tests. I will go with the Taj Mahal to be different.
You don't have to be different, Addie.
I know.
It is the Millennium Falcon.
I know.
And I deliberately put it A because I almost never have the right answer A.
There you go. We reverse psychology, dude.
All right, well,
It was the Millennium Falcon, yeah.
it is one of the Millennium
Not the
Falcons.
newest one.
now I have to guess how many
Follow-up
pieces?
is how many Millennium Falcons has Lego produced?
But
See,
I thought we had to
this
I thought we had to
question.
give the number of pieces to that.
You do also have to give the number of pieces.
okay.
I'll give you a multiple choice for the number of pieces. I'm only going to give you 4 choices because the Titanic is not a Lego set.
I wondered about that.
Yeah.
Okay.
So here are your choices: 5,923, 4,016, 6,020, 8,019.
8,019.
I'm going to go with the 6,000.
I'm a damn dirty liar because I didn't actually read the right number because I realized that the way I phrased that question, I was giving away the answer.
Yeah,
Because I was just reading the numbers of the pieces.
Yes,
Yes, of the sets. Right. So it's just going to be the biggest
He
number.
said there's only 4 options because these are the 4.
Right, yeah.
yeah.
It's 7,541.
The right answer wasn't even in there?
That's correct.
That sucks.
I said
we
I
were
was a
both right.
liar.
We're right.
We win. We win.
High five.
Yes.
You do win. I screwed up the asking of that question, so you both win. Number 2 is Hogwarts, 6,020.
Okay. How much does Taj Mahal have?
5,923. Just super quick. How many versions of the Millennium Falcon? I don't care if we did it before.
5.
5.
You're both right. It would have been weird if one of you had been right and one of you had been. You're killing this, you
Yeah,
guys.
we're all over this.
Which, in your final follow-up Lego trivia, which of the following real space vehicles has not been rendered in an official Lego set?
Okay.
And all this stuff is really right up Addie's alley. Addie's alley would be a great name for some kind of place.
Okay. My brewery can be called Addie's Alley.
Your what?
My brewery.
What's that?
Brewery and bakery.
Yeah, that's perfect. Which of the following real space vehicles has not been rendered in an official Lego set? The Apollo Lunar Excursion Module, the Mars Curiosity Rover, the Space Shuttle, the Mars Exploration Rover, that's Spirit and Opportunity, the smaller ones,
What was the first Mars one you said?
Mars Curiosity Rover, or Skylab.
Curiosity.
Exploration.
Oh, I gotcha. Skylab.
Skylab.
Yeah.
There's a Curiosity?
There is a Curiosity and a Mars Exploration
I have a
Rover.
Mir.
They're both, impossible to get and impossibly expensive.
I have a Mir.
Congratulations.
I also have 2 space shuttles. An
Those are
ISS.
also popular and hard to get, and a lot of activity goes on with people designing new versions of them.
Yeah.
And everybody's obsessed with
I have
making
an ISS.
Lego
Yeah,
space
we
shuttles.
just finished building our ISS.
It's fun. It's got little teeny tiny astronauts.
Yeah.
Little teeny tiny what?
Astronauts.
Oh, yeah.
Yeah.
It's this big.
Yeah. Well, while it may have felt like the time to binge watch an entire series online, it was just another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, be sure that you and at least 5 friends like us on Facebook to push us over the 1,000 likes threshold.
We can do it.
When we hit that, we will have a special surprise. I won't say what it is, but I will remind you that this is the Naked Astronomy Podcast. And there is your callback to the beginning of the
Nice.
show. Check out our website at walkaboutthegalaxy.com where you can see our sweet Walkabout tees to show your fine taste and help support the show. Subscribe to our YouTube channel, Walkabout the Galaxy, where anything untoward is, of course, tastefully blurred. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Production assistance is provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in the state of Victoria, Australia, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the AstroQuarks signing off until the next episode of Walkabout the Galaxy.